just pause and just stare at these beautiful pictures. Just make sure that you have the whole concept here of what we went over and which of these had the answers we were looking for, okay? So with that, let's move on to question number 9. Hopefully you had enough time to pause and just kind of review that. Oops. Whoops. There we go. So question number, I think I zoomed in too much. There. Question number 9. What is a formula for potassium nitride? Okay, so for this we have to know what we're dealing with in regards to what they mean by nitride and potassium. Potassium is relatively straightforward because we just get it straight from its name, okay? So that one would just be K. Nitride, though, that was a little bit trickier because it's actually going to be, the rule is that if it ends in IDE, it's typically just the element by itself. And what element? The nitr part, N-I-T-R, which is actually just nitrogen, okay? So we have a potassium and a nitrogen, okay? If it was like nitrate, that'd be NO3, which is completely different. That's a different ion. Nitride, we're only dealing with nitrogen ions, okay? So with that being said, we have to figure out, you know, what the actual bond distribution will be. So with that, nitrogen, okay, has, it's on the 15th column, meaning that it have 5 electrons. So to get to its filled shell, it'll just rather add 3 than remove 5. You can also support this through the electron configuration. Okay, start at helium and be 2s2 2p3. This also supports that it has 5 in its valence shell. With that being said, it wants to then just add 3 more rather than get rid of all those 5. Potassium, on the other hand, all the way over here in the 4th row. So with that being said, you know, we have argon, okay, and then we just have 4s1. So now we have 4s1, 2s2, 2p3 in total. For potassium, it only has 1 valence. Nitrogen, 5 valence. Potassium has an easier time getting rid of 1. So typically a potassium ion would just be K+. As we discussed, nitrogen wants to add 3, and if you remember, adding electrons means that you actually have a negative sign, so 3 minus. For this to be a neutral compound, we need to have the same amount of positive and negative charges. So with that being said, we need 3 of these K's to make up for the 3 negative on the nitrogen. So we have K3N. This is a formula for potassium nitride, okay? So with that being said, as we look at the answer, K3N is a chemical formula. Oh wow, it actually does even go through the electron configuration. I thought I was the only one doing it. I'm glad it answered the question like that because I personally love just emphasizing the electron configuration. So with that being said, on the other hand, nitrogen, yep, 2s2 2p3 shows that it has 5, and because it'd be easier to just add 3 more to become the octet, that's what it does. So when it forms together, we have K3N. It's nice to even give us the molar mass, which is calculated by adding the atomic masses of 3 potassiums and 1 nitrogen. And these are just some reactions that are involved. But overall, this right here is correct. So hopefully you understand how we got potassium nitride. We first have to understand what the IDE meant for the nitride, okay, which is where we just gave it to get the nitrogen, and then we balance the charges based on where they were on the periodic table / their electron configuration. So now let's move on to question 10, okay.